Hi there again. This is an Algebra 1 video. It is Chapter 4, Section 2 for Algebra 1. And in our previous lesson, we learned how to graph equations, linear equations, in slope-intercept form. And today we're going to learn how to write equations using slope-intercept form. So once again, I want to remind you that our slope formula was y equals mx plus b, and we know that m is the slope of the equation and the point 0b is the y-intercept. So, example 1 says, write an equation of the line that passes through 2, 1. So this is my x-coordinate and this is my y-coordinate with a slope of 3. So what we're going to do is we're going to try to find the y-intercept. We were not given the y-intercept. If we had been given the y-intercept, the x-coordinate would have been 0. But that doesn't mean that we can't solve going backwards using y equals mx plus b. So what we're going to do is we're going to replace everything we know with the equation. For example, we know that the y value is 1 if it's going to pass through that point. So we put a 1 in the place of y. We know that the slope is 3, that's m. And we know that the x-coordinate is 2. Because of the x here. So what we don't know is what b is, and that's what we're going to solve for. So now we have a very simple equation. 3 times 2 is 6. And to solve for b, we're going to subtract 6 from both sides. And so at the end of the day, we're going to get that b equals 1 minus 6, which is negative 5. Once we know what b is, we can go ahead and put it back into our equation. And so our final answer is going to be y equals m, which is 3, x, and then b is negative 5. So this will be the equation of the line that passes through 2, 1 that has a slope of 3. So if you would like to do example or do yourself number 1, you can go ahead and do that now. In our next example, we are going to go ahead and do the same thing, only this time we're going to be having to do an extra step because as you can see, we don't know what the slope is. They did not give us the slope this time. They did give us the point that it's passing through. They actually gave us 2 points that it's passing through, and we can choose whichever one we want to be x and y, but we don't know what the slope is. Well, what we're going to have to do is we've already learned in the past how to calculate slope, so what we're going to do is we're actually going to calculate the slope by doing x1, y1, x2, y2, and then we're going to go slope is equal to y2, which is 4, minus y1, which is 1, over x2, which is 2, minus x1, which is 3. So we're just going to plug it right into the slope formula. 4 minus 1 is 3, and 2 minus 3 is negative 1, so my slope here is negative 3. So now we're back to the same situation that we were in earlier in our previous example, where we know the slope, and we have 2 points to choose from. It doesn't matter which one you choose. I'm going to go ahead and choose the second one just to show you that it's the same thing. So remember, we're going to replace the y with the 4 because that's the y-coordinate. The m we've got is negative 3. The x value for this point is 2. And then plus b. Now remember that once you've chosen to use this y-coordinate, you have to use this x-coordinate. You can't take this y-coordinate and the x-coordinate from this point. You have to be consistent with the point that you've chosen. So now we're going to get 4 equals negative 3 times 2 is negative 6 plus b. We add 6 to both sides, and it turns out that b equals 10. So now we go back and we write our final answer. Y equals our slope, negative 3x, and our y-intercept, positive 10. So that's the equation of the line. We'll do the same thing over here. So we will take x1, y1, x2, y2 and calculate the slope first. So y2 is negative 6 minus y1, which is negative 2, over x2, which is negative 5, minus negative 4, which is x1. And remember that these negatives, double negatives, can be kind of tricky. So a negative makes a positive, and negative 5 plus 4. So we're going to get negative 6 plus 2, which is negative 4, and negative 5 plus 4 is negative 1, and a negative divided by negative is positive, so our slope is 4. Now we're going to plug in that what we know. And so we're going to get, I'm going to use the first point this time. So y is -2. My slope was 4. My x-coordinate is -4. Once again, making sure that I stay consistent with using this y-coordinate and this x-coordinate, plus b. So 4 times -4 is -16. And then we add 16 to both sides, and we end up with b equals 14. So my final answer will be y equals 4x plus 14. And that is how we find the equation of a line that passes through two pairs of points. Alrighty then. Now you can try these couple of examples on your own, and then we will move on to our next example. Alright, so here we go. It says in example 3, the table shows the number of domestic flights in the U.S. from 2004 to 2008. Write an equation that could be used to predict the number of flights if it continues to decrease at the same rate. So what we want to do is we want to find the equation of the line, and this is pretty much the exact same thing that we did in the previous lesson. We don't know what the slope is, but we can calculate the slope by choosing to use two of the points. It doesn't matter which 2 points that you pick. So you could pick, for example, I'm going to go ahead and pick 2005 and maybe 2007. But I do need at least 2 points so that I can plug it into my slope formula. So what I'm going to do is I'm going to put over here I don't want to have such big numbers. So I'm thinking what I'm going to do is we're going to say year, and we're going to put up here since 2000. So we're going to let the number 0 represent the year 2000. And if the number 0 represents the year 2000, then the number 5 will represent the year 2005. So what I'm going to do is I'm going to get 5 for my x-coordinate, and my y-coordinate will be 10.04. And then for 2007, it'll be represented by the number 7 and 9.84, like this. Now I can go ahead and do my x1, y1, x2, y2, and I'm going to calculate my slope, 9.84 minus 10.04, and then 7 minus 5 on the bottom. 7 minus 5 is 2. 9.84 minus 10.04 is negative 0.2, and negative 0.2 divided by 2 is going to equal negative 0.1, which should make sense because the number of flights is decreasing, so it makes sense that our slope is negative. So now we're going to do what we did in the previous examples and try to find the equation. So I can choose either one, so I'm going to go ahead and choose the first point. So for y, I'm going to put 10.04 equals my slope, which is negative 0.1, times x, which is 5, plus b. So I'm going to get 10.04 equals negative 0.1 times 5 is negative 0.5. And then we're going to add the 0.5 to both sides. And then b is 10.04 plus 0.5, which is 10.54. So to write out my final answer, I'm going to get y equals my slope, which is negative 0.1x, and then plus 10.54. And that will be my equation that could be used to predict the number of flights. Now, in example 4, we're actually going to use that equation to predict. But first, you want to do this, do it yourself, number 3. And then we have number 4, which again, it doesn't say so here, but you can see that it's talking about domestic flights again. We want to refer back to example 3 And now it's asking us to estimate the number of domestic flights in 2020. So we know from before that if 0 represents the year 2000, then 20 will represent the year 2020. And I have an equation which was right here, y equals negative 0.1x. So I need to grab that guy. Y equals negative 0.1x plus 10.54, I do believe. I want to double check that real quick. Yes, plus 10.54. All right, so all that we want to do is now we're going to predict using our equation. So all we're going to do is we're going to replace the x with 20. So we're going to say y equals negative 0.1 times 20 plus 10.54. And negative 0.1 times 20 is negative 2 plus 10.54. So we're going to get that y equals 8.54 millions of flights. All right, so you can see that when we have an equation, we can actually use that equation to estimate the future. So it makes sense that we're going down in numbers. So in 2008, if we go back to our chart here, in 2008 we were at 9.37. So it just means that 12 years later you would be all the way down to 8.54 for the number of flights. So anywho, that's basically how you do that. And now what I want you to do is this do-it-yourself question is referring, again, you're doing the same thing, you're predicting with the equation. In example 3, in do-it-yourself number 3, you should have come up with an equation, and then you want to use that equation to predict for the 8 deliveries. Once you've done that, you will have completed your notes for this lesson, and I will see you in class, and thank you for watching.